Use the different shading shown in the rectangle and use our definition of multiplication to explain why 3 times quantity 2 plus 4 in the parentheses equals 3 times 2 plus 3 times 4. Your explanation should be general in the sense that you could use it to explain why A times the quantity B plus C in parentheses is equal to A times B plus A times C for all counting numbers A, B, and C. So if we look at the picture we have here, typically if we want to find the total number of squares, we would take the number of rows and we would multiply it by the number of squares in each row. That's our typical area of array model. So the problem with this one though is that we essentially kind of have two separate arrays. We have our orange array and we have our green array. And so how could you approach this then if you have two different arrays and you want the total? So there's a couple of approaches that you could take. One is you just put them together, right? So we would put these two together and say, let's make one array out of these two, right? As long as they have the same number of rows, that would work. And so when you look at this first half of the equation, 3 times the quantity 2 plus 4, this is saying we have 3 rows in this case, right? Rows go across. And we're going to multiply that by, where does the 2 come from? 2 comes from the number of red squares in each row. And the 4 comes from the number of green. And again, that's not a total red and total green, that is per row. So what we could do is we could say, well, if I put them together, I don't need to figure out the red and the green separately. I'm just going to put them together and say, well, 2 plus 4 is 6, right? So this is doing what's in parentheses first, or following order of operations. We could say this is really 3 rows times 6 squares per row. So by putting them together, I'm kind of saying I don't care about the differences in color. And then I'm just doing 3 times 6, which would give me that there are 18 squares in total. So that's one way to think of it, but then I could also think of this using the distributive property. So if I were to distribute my 3 inside the parentheses, I'd get 3 times 2 plus 3 times 4. So if I do it that way, then I'm actually going to do the 2 colors separately. So this would be like saying 3 rows times 2 orange, or red, I guess is what I call them. Red, orange, whatever you think that is. So 2 red squares per row. And then I'm also going to do 3 rows times 4 green squares per row. I just changed it red just because that bothered me, just to make it red and green, or orange if you want to make it orange. So doing it this way, 3 rows times 2 red squares per row, that's basically thinking of these as separate arrays. So now, how would I find the number of orange or red row squares? I would multiply 3 rows times 2 red squares per row, and I would get that there are 6 red squares in total. And then to find the green, I would look at that one separately and say, well, that's 3 rows times 4 green per row. So that's a total of 12 green squares. But then, so this is thinking of it separately, but then in the end, you just add together your red and your green and we still get that there are 18 squares in total. So it's just a matter of, do you want to think of it as I'm going to put these 2 things together and make it one big array? Or am I going to think of it as 2 separate arrays, one red and one green? So to generalize this, we can say that this would be the same no matter what numbers, right? Because it says it wants the explanation to be in general for any numbers, A, B, and C. So you can imagine A being the number of rows, and then there being B red in each row and C green in each row. And so if we think of it that way, then we're just saying for any numbers, this would work. So for any numbers, A, B, and C, we can add together B plus C to find the total number of squares per row, then multiply by A rows. Or we can multiply A times B to find the red squares, and A times C to find the green. Then add to find the totals. So the point is, it's just two different ways. The point is that they're equal. So this demonstrates again the distributive property, and it works for any numbers. You could have any number of rows, any number of red, any number of green, and this would still work.